All right, welcome back, everybody. So we're working on our textbook today. You can find this, Forms of Quadratic Functions, on page M1-54. And again, that's in volume 1 of your textbook that you got. So the idea behind today is, I know we picked out all of these key characteristics like the intercepts, the vertex, axis of symmetry, concavity, and we also did domain and range. And that was when a quadratic function was already graphed for us. So today we're going to find these things, but instead of having a graph, you're just going to be looking at functions or function forms. So there's 3 different types for quadratic functions. You've got standard form, vertex form right here, and then of course factored form. It's got the variables listed for each, and I'll walk you through and tell you which ones apply to which characteristics down here. Not a difficult process by any means, but let's just get to it. So on question 1, right, the form of a quadratic function reveals different key characteristics. State the characteristics you can determine from each form. And this is just by looking at them. Right off the bat, you're going to know a couple of things based off of which form you started on. So let me get rid of that page number. Okay. For standard form, there's 2 things that you can find right off the bat just by looking at it. One of those things is the y-intercept. And how you find the y-intercept is look at C. If you forgot what C was, just look at the top of this page and it'll show you where C falls in standard form. The other thing that you can find just by looking at it is concavity. You can determine if it's concave up or down just by looking at the function. And to do that, you would just be looking at A. You're going to look at that very first value, which is known as A. Now, factored form, different things to find in factored form. Really, the only difference is instead of the y-intercept, you're going to be able to find the x-intercepts very easily. X-intercepts. And to do that, you would just be looking for R1 and R2. Okay. Factored form, also easy to find, concavity. And of course, that's just because of the A value. Just look for the value of A, and it'll tell you whether it's concave up or down. Vertex form, obviously has some different uses. Believe it or not, it's really easy to find the vertex there. So the vertex, remember the vertex literally is a point. So the vertex, the point, it would be the value of H and also the value of K. That's how you find the vertex when a quadratic is written out in function form and not graphed for you. So hey, if you don't remember, the axis of symmetry, it's another easy thing to find when a function is in vertex form because the axis of symmetry always passes through the vertex. And which part of the vertex does it pass through? It passes through the vertex's x value. So the axis of symmetry, it's also found just by looking at that h value. Okay, same thing. Axis of symmetry always passes through the x value in your vertex. And just like with all our other forms, we can also find concavity very simply. And of course, you're just looking again at the a value. Just look at the a value. So I'll walk you through an example of each one of these real quick. I'll just do it kind of on the notes section here on the left. I'll scroll up so you can see the forms here. Okay, so let's walk through an example of standard form. So I'll write a function note here for you. Let's do f of x. Let's do f of x equals. Again, I'm just following this format. So a, b, and c are things that are going to get replaced. So I have like negative 4x squared plus 16x. Let's do plus 3. Okay, so if you remember what I wrote down there, there's two key characteristics that we can find just by looking at standard form. So the first thing I'll write out is the y-intercept. Y-intercept. Again, the y-intercept, all you have to do is look at that c value, that number on the end, which is 3. So the y-intercept is going to be at 3. It's going to cross the y-axis at 0, 3, to be more specific there. Hey, so then concave, for concavity, is this going to be concave up or down? So again, for concavity, all you have to do is look at the leading value, leading coefficient, which is -4. So that sign is what's going to matter. Since it's negative, your function is going to be concave down. Okay, and that's really it. Those are the two things for that you can spot right off the bat from standard form. So here's an example for factored form. I can have another function of x be equal to, and so this time I'll just not have an a value seen. Let's do x minus 5 times x plus 3. You ought to get better with the handwriting here. X minus 5 times x plus 3. Okay, so again, factored form, very easy to find x-intercepts. X-intercepts. So those will be, okay, so actually let's say this. X-intercepts, those have two other names, essentially. X-intercepts are also known as solutions, and they're also known as zeros. So when you're looking at this first group here, what x value makes this equal to 0? What minus 5 equals 0? What x value makes this factor equal to 0? And hey, so that would be x equals 5, because 5 minus 5 is 0. In the other factor, this r sub 2 term over here, again, what makes this factor equal to 0? X would be equal to -3, right? If I plugged in -3, well, that would mean -3 plus 3 is 0, and that's what you want, okay? Now, you can also get concavity from this, so we'll just list it out. Is this going to be concave up or down? So look at that very first term. I know it's not implicitly like listed for you right here, but you can assume that there's a 1 in front of it, if it helps you out. And what's the sign of that 1 then? Well, it is positive. So this would be concave up. Your graph would be facing upward, or your parabola would be facing up. Okay, kind of ran out of room here. Let me clear this, and we'll do one more example. And this one will be for vertex form. So let me get another function going. We'll have a function of x equal to negative. So I'm following this format now, right? Vertex form, negative x plus 7 squared. You know them on the end as well, so we'll do -4. Okay, kind of the same idea. So we need to do, let's do the vertex. First key characteristic you can find right off the bat. So the vertex, again, it's the value of h and k. It's a point, it's an actual point here, where the x value is equal to this inside parentheses, and the y value is equal to this number on the end. But again, kind of like what we did with factored form, you're essentially going to make this equal to 0. You're essentially making this equal to 0. So what x value makes this, in parentheses, equal to 0? That would be -7. And then the y value, it's not in parentheses, there's nothing else to really do to this, so it is literally just -4. So the vertex of this parabola, you would go like starting on a graph, and that looks awful, but hopefully you get the idea. You'd have to go left 7 and then down 4 to find your vertex. All right, so then the next part of this, once you have the vertex, very easy to find the axis of symmetry, because the axis of symmetry passes through your vertex, passes through the x value of your vertex. So x would be equal to -7 there. So like there's a line that cuts our parabola in half, and that would be at -7. All right, so the last thing on vertex form that you can find is, or determine rather, like, is this concave up or down? So again, look at the leading value of A up here. So it's kind of that value in front of the parentheses when you're in vertex form. And again, you can be, or it's understood that there's a 1 in front of the parentheses. So what was the sign then of that value? I had a negative sign in front, so this would be concave down. That's about it. Those are the key characteristics that you can find just by looking at the function forms, the actual equations here. So let me get rid of all this, and I'm going to show you the next page just to be aware of it. So like Christine here, she started off with standard form. She's got a value of A and then B and then C. And then Kate started off in factored form. There's 2 different factors, right? And so she has a 0 then, right, at -3. And then she also has a 0 at +7, as she kind of lists down here. And again, zeros and x-intercepts, referring to the same thing. So what I'm just trying to say here is that even if you start in standard form or factored form, you can still find the axis of symmetry. So these 2 formulas are actually going to be very important later on in the week. This x equals -b over 2a, x equals -b over 2a, and this, where you kind of find the average of your x-intercepts. These 2 things are going to be important again later in the week. You can find your axis of symmetry and then plug those in, let me clear this, to get a y value for a vertex. So I'm not going to go into that today. Just be aware that we are going to get there. So even if you're given one form, you can find all of the key characteristics. And it's not a terribly difficult process or anything. But anyhow, let's look at these graphs over here. So I've got 3 different functions. One of them is in standard form, one's in factored form, and then one of them is in vertex form. So if you can, just look at these and try to determine which one is which one is standard, which one's factored, and then which one is in vertex form. And so we'll just pick out the key characteristics, and then we'll sketch a graph over here and just see how we compare. So let's start off with the first one. I have got standard form. So I know one thing that's going to be very easy to find is the y-intercept. It's this value on the end. So I have a y-intercept at -4. I know my parabola is going to pass through this point. Not much else to go by, though, on standard form. I know it's going to be concave down. I know my function is going to be facing down. And actually, let's just find the axis of symmetry on this one to help our graph. So again, the axis of symmetry, so again, I'm finding the axis of symmetry. When you're in standard form, that's going to be x equals -b over 2a. Plug these things in. So I'm doing negative the value of my b term, which is 4, divided by 2 times the value of my a term, which is -2. Okay, so that becomes -4 divided by -4, which simplifies to +1. All right, so I know my parabola reflects off of this line. So I just did that to make our graph a little bit more clear, make it a little bit easier to graph. Okay, so once again, we have a y-intercept, and I know my function's concave down because of this negative value, -a value. And my vertex is going to pass through this axis of symmetry. So here, let me just sketch this for you. So my parabola, it's going to come from down here, reach a y-intercept, come up to some highest value, and then start to come back down. Okay, so that's what our function should look like. So let me hit the button over here to graph it. And so you see, like, not perfect by any means, but we didn't have a lot to go off of. I knew the y-intercept though, and I knew I had an axis of symmetry passing through 1. So not everything's lined up correctly. Like, I'm a human, I make mistakes graphing this, but you get the right idea, hopefully. So hey, let me get rid of this stuff We'll move on to our next function, find some key characteristics of it. So I don't need this one anymore. Okay, so this one, it's in factored form. So that means I can find very easily, pretty easily the x-intercepts. So let's do that. What are my x-intercepts here? X-intercepts, they are going to be at, so again, you're just looking at the factors. Something minus 3 is going to be equal to 0. So I can just do this one for you. X minus 3 equals 0. If I add 3 to each side of my equation, I get x equals 3. So I know my function is going to pass through this. Let's just do my other one. So x plus 2 equals 0. If I subtract 2 from either side of this equation, I'll get x equals negative 2. So I have another x-intercept way out here. So the value here, the value is not going to matter for us too much right now, but the sign does. Since it's negative, I know for a fact that this function is going to be concave down. Oh, I looked at the wrong one. I'm so sorry. We're on this. We're on this. In front of the 5, that's not negative, that's positive. So this is positive or concave up. Sorry about that. Okay, so again, later on in the week, we'll find the active symmetry for this, and plug that in to find a vertex, but not too worried about that right now. So since it's concave up, my parabola would be starting somewhere up here, have to go down to pass through negative 2, eventually curl back upward to go through positive 3. Okay, so then that is a terrible sketch, but let's just see what it looks like. Yeah, not close, but our key characteristics is really what we're looking for. I knew that my parabola was going to be facing this direction, which it's doing, and I know that it's going to pass through this point and this point, right? Our x-intercepts, I knew I could find those just by looking at the function rule over here. All right, so let's do the last one. It actually tells us the most information. Let me clear this. I'll get rid of this function. Don't need it anymore. All right, so our last one, vertex form. A lot to do on this one, right? Kind of. So our vertex, let's find the vertex first. So the x value is going to come from this in here. And again, I'm changing the sign of this value. So my vertex is going to pass through negative 2. And since this one doesn't have anything really with it, that's just that value, it's just 3. So your vertex, left 2, then it looks like I'm having to go up 3. Vertex is going to be just about right there. And for what it's worth, right, our axis of symmetry, when it's in vertex form, very easy to find. The axis of symmetry will be at x equals negative 2. It's going to go like this. One more thing to find in vertex form, just by looking at it, and I kind of already did this one already, but there's a negative sign in front, so that's how you know it's going to be concave down. Okay, so without sketching it this time, because it looks so bad, let's just put the graph up and just make sure that we certainly do have the vertex in the right spot. So let me plot this real quick, and there you go, you see it. Parabola, it is concave down. You can tell that it's opening up downward, and our vertex was in the correct spot. Negative 2, positive 3. All right, that is gonna do it for this video without a doubt. Appreciate you guys watching, and I will see you.